Here is a quick review on inverse trigonometry, which helps you find missing angle measures in right triangles. Here's my right triangle, and I've labeled the sides relative to theta. And SOHCAHTOA, we've seen in previous videos, helps us figure out missing side lengths. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Well, we can use inverse trig to help us find missing angle measures. And you need to know two of the side lengths in order to use inverse trig, but if you have that, you can find those missing angle measures. Let's look at our first example. I've got my theta, and I have two sides that are 10 and 20 units long. I've labeled all my sides here relative to that theta, but I really only need that opposite and hypotenuse because those are the two side lengths I know. And looking at SOHCAHTOA, we're going to want SO or sine because the sine of theta is opposite over hypotenuse. So let's substitute in our value. Sine of theta is 10 over 20, which is 1/2. And now I'm going to have to use inverse functions, which swap my inputs and outputs to figure out what theta is. So I'm going to take my input theta and my output 1/2 and swap them around because that will give me what theta is. So I can't just simply turn them around. I've actually changed my function now. It's not sine anymore, but it's inverse sine, and that's what that little -1 means. I'm just going to use the symmetric property of equality, put my theta on the left side since I prefer to have the thing I'm solving for on the left. And then I'm just going to use my calculator. I'm using the Desmos calculator to figure out this value for us. And I'm using just the default generic Desmos version. Or what calculator you're using, you want to click on this wrench here or any settings that your calculator has because we want to make sure we're in the right units, and we are doing all our calculations for this video in degrees. If you're using the default Desmos calculator like I am, it will default to that other unit called radians. So we're going to click that to be degrees. If you're using the Virginia testing version of the Desmos calculator, it should default to degrees, but you never know when something might change. I highly recommend always clicking on that little wrench button. It takes a second just to make sure you're in the right mode. So here we are in degree mode. Then we're going to go to the lower left screen and click on the keyboard icon. We're going to go over here to the right where it says functions. There's a bunch of different functions. Make sure you're on the trig function. And here are all my inverse trig functions. We don't really use the cosecant, secant, or cotangent in our class, but you will in the future. But since our first calculation is we want to find the angle whose sine is 1/2, I'm going to click on inverse sine. And then I'm going to type in my fraction here, 1/2. And it tells me a 30-degree angle is the angle that has a sine of 1/2. So the angle whose sine is 1/2 is 30 degrees. In our next example, I have an opposite side, the 19, and an adjacent side, 35, to that angle theta. So opposite, adjacent, that's tangent, the TOA of SOHCAHTOA. So tangent of theta is opposite over adjacent. So let's substitute our values in from the example. Tangent of theta is 19 over 35. So I want the angle whose tangent is 19 over 35. I'm going to swap the inputs and outputs. And now I'm using inverse tangent. The angle whose tangent is 19 over 35. I'm going to use the calculator again to find the angle measure. Now this time we want to figure out the inverse tangent of 19 over 35. So I'm going to, again, I always click my wrench. I always check, still in degree mode. And then I'm going to click on my keyboard. I'm going to select functions. I want inverse tan this time, inverse tangent. And I want the angle whose tangent is 19 over 35. Getting this number here. And if I round to the nearest tenth, say, it'll be 28.5. So that angle measure is 28.5 degrees. In my final example, I've got an adjacent side and I've got a hypotenuse. The 17 is the adjacent side and the hypotenuse is 25. Adjacent, hypotenuse. That's the ka in SOHCAHTOA. Cosine is adjacent over hypotenuse. So the cosine theta is adjacent over hypotenuse. Let's substitute in our values. The cosine of theta will be 17 over 25. I'm going to want to swap my inputs and outputs, which means I need to use inverse cosine. The angle whose cosine is 17 over 25. That's what inverse cosine will return. So I'm going to use my calculator. Once again, back in the Desmos calculator. Super quick, still degrees. And this time I want the angle whose cosine is 17 over 25. So I'm going to click on my little keyboard, go to Functions. I want inverse cosine this time. And I want the angle whose cosine is 17 over 25. And there it is. To the nearest tenth, about 47.2. So the angle whose cosine is 17 over 25 is approximately 47.2 degrees. So while our sine, cosine, and tangent ratios are very helpful in finding missing side lengths, we can use their inverses to find missing angles. I hope you found this a little bit helpful. Thank you so much for watching.